Sarah, let us go through a major machine learning approach under the supervised machine learning, that is decision tree learning. So first we understand what is a decision tree and tree representation, tree construction and its illustration, and one of the popular machine learning decision tree approach, that is ID3 algorithm, iterative dichotomizer algorithm. First, understand what is decision tree learning, exactly what is decision tree in machine learning. In machine learning, decision tree is used to make a binary decision majorly, that is yes or no or 0 or 1 on a problem with the underlying information. So the underlying information is called a data set. The data set contains multiple parameters and these parameters are called as attributes. It is also referred as a training set and also referred as a labeled set. So attribute can take binary value, multi-value, or it may be numerical values. Decision tree mimic human thinking ability while making a decision, so it is easy to understand. That's why it is considered as one of the most popular approaches of classification technique. So the decision tree classifies instances by sorting them down the tree from the root to some leaf node. So which provides the classification of the instance. So in the decision tree, what actually we are able to represent that the inner node represents an attribute, the edge or branch represents an attribute value, the leaf represents a class, the paths from root to leaf represent classification roles, and the decision trees represent a disjunction of conjunctions. So we will see in the example what exactly this disjunction of conjunctions, and each path from root to leaf is a conjunction of attribute tests. The tree itself is a disjunction of these conjunctions. So first let us understand decision tree actually comprises of the root nodes, intermediate node and the leaf node. The leaf node is the one which actually refer to the decision, that is either yes or no if it is a binary classification. So for example, let us observe here a sample decision tree, that is we can see here, that is the decision node, that is the root node, and I told you about the intermediate nodes, that is the decision node, and then in the leaf node you can see here, that is which actually contain the decision. So it can have any number of branches, and then related to the branches, so the leaf node contain the actual result, that is it belongs to, the decision belongs to which class or not. So the decision tree terminologies, let us understand one by one. The root node is from where the decision tree starts. It is very important. We also consider it as a starting point. It represents the entire data set which further gets divided into two or more homogeneous sets. Next, the leaf node. The leaf node are the final output node, and the tree cannot be segregated further after getting a leaf node since it contains the decision. Splitting is a process where dividing the decision, that is the root node, into subnodes according to the given conditions, where the branch or subtree is a tree formed by splitting the tree. Pruning is the process of removing the unwanted branches from the tree. So this is done only when the decision tree has been constructed, and then we got to know that so it has some unwanted branches are there, so only then will be subject the decision tree to the pruning. Next, the parent or child node. The root node of the tree is called the parent node and the other node are called child nodes. For example, whenever we are going to construct a decision tree, so we need a training set, or we can also say it as a labeled set. So where we can observe here, it has the instances. So altogether here there are 14 instances are there, and then instance has certain attributes. In this case there are 4 attributes, and here all the attribute values of type discrete attributes, and we can see here at the last we have a target, that is we can say the label, that is no or Yes. So depending upon the instance and related attribute, so we are able to see the label as no or yes. Since it is a binary classification, so we have only the two classes, that is yes class or to the no class. And here we are going to take the decision that a person is going to play the tennis or not. So depending upon the conditions, that is what conditions here, weather conditions, how we are able to end up into a decision, that is that tennis game can be played or not. So next we'll be observing how the tree get represented, how actually it look. For example, we can observe here, we have chosen an attribute called outlook. So now it is very important that among n number of attributes in the data set, so which attribute is considered as a root node. So in order to do that, so we are going to conduct the statistical test measures. So using that, we are going to determine which attribute is considered as the root node. It is also considered as the feature selection technique. So we are selecting the attributes which is going to give contribution, that is what sort of contribution to the decision making. Such attributes we are selecting, and among that one attribute majorly we are considering it as a root node. So based on this, the data set is partitioned further. So we can observe here, it has the left branch here, we can observe here. So with the node again, the humidity, that is each internal node tests an attribute. And again, we can observe here under this related to its attribute values, that is high and normal, that is intermediate node, that is at the leaf node, we can see here that is related to the classification. So once we realize how actually it is constructed with the algorithm, so it will be very clear for us how to construct a decision tree and how it can be used for further classification. So decision tree expressivity, that is decision tree represent a disjunction of conjunction and constraints on the values of attributes. So now we will see that how the decision tree algorithm works. What is the first step? Begin the tree with the root node, that is here we are considering it as say S, which contains the complete data set. Second step, find the best attribute in the data set using attribute selection measure. Since here in the decision tree, there are different approaches are there. So here we are discussing about iterative dichotomizer ID3, that is algorithm. So we are constructing the decision tree using this algorithm. And here we are using the two different measures, that is attribute selection measure. So we call it as entropy in the initial level while selecting the attribute values. By using that, we find the entropy, and then using the entropy, we calculate the gain. Gain is nothing but the contribution of the attribute in the classification decision. Next, we divide the yes, that is nothing but so the root node into the subsets that contains possible values for the best attributes. Next step, generate the decision tree node which contains the best attribute. Next, fifth step, recursively make new decision trees using the subsets of the data set created in step 3. First, we have to choose the root node. Then once the root node is chosen, then we are going to partition the data set according to the possible value for the attribute values related to the root node. And then we are going to continue this process until a stage is reached where you cannot further classify the nodes and call the final node as a leaf node. So let us first understand what do you mean by entropy. Entropy measures the level of impurity in a group of examples. And we can see here that as a very impure group, that is the data set collection. We can see the examples here, and which is less impure, and it is the minimum impurity. So now we can observe here with some pictorial representation that is high entropy means it is a messy thing, and the low entropy is the clean one. Means, so we are going to observe the attribute values, that is with the entropy, if it is lower, then we can say that so its contribution will be more. So in that way, that is the purity will be more. So first understand what is entropy. It defines and measures randomness in the data. It's a metric which measures the impurity, and we can also observe here according to the information theory, it is the minimum number of bits of information needed to encode the classification of an arbitrary member of example space S. If the target attribute can take on C possible values, the entropy can be as large as log 2 to the base C. So first, let us represent what actually the entropy is. So it is going to vary between the range that is 0 to 1. And then here we can also observe here. So S is a sample of a training example. So how we are calculating the entropy of the sample, that is nothing but it's the proportion of positive examples, that is again log 2 to the base of proportion of positive examples, then minus proportion of negative examples log 2 to the base of proportion of negative examples. So using this, we are going to calculate entropy of the training example. So first, let us realize this through an example. Suppose S is a collection of 14 examples of some Boolean concept, including 9 positive and 5 negative examples. Then the entropy of S relative to this Boolean classification is, that is E of S is equal to minus P plus, that is nothing but proportion of positive examples log 2 to the base of proportion of positive examples minus proportion of negative examples, again log 2 to the base of proportion of negative examples. So we can see here that as in the data set we have totally the 9 positive and 5 negative. So we are using here in this case, so we are using here in this case 9 positive examples, and in that we can also observe here. So whenever there is a representation, so we are considering it as altogether how many positive and negative examples are there. That is altogether 9 by 14 log 2 to the base of 9 by 14, then minus 5 by 14 log 2 to the base of 5 by 14. So now we have also, it is important to realize that, that is if the entropy is 0, so if all members of S belonging to the same class, the entropy is 1 when the collection contains an equal number of positive and negative examples. If the collection contains unequal number of positive and negative examples, the entropy is between 0 to 1. So how to calculate the entropy? So now we have gone with taken with an example, already gone with this. That is 9 by 14 log 2 to the base of 9 by 14 minus 5 by 14 log 2 to the base of 5 by 14. So when we calculate this, we got the value as 0.940. That is nothing but what? Entropy of the sample. So next we use this entropy, that is to calculate the information gain. So it measures how well a given attribute separates the training examples according to their target classification. So information gain uses the notion of entropy commonly used in the information theory. That is nothing but information gain is altogether, it's an expected reduction of entropy. So let us analyze this with an example and also related to the formulae. Is the expected reduction in entropy caused by partitioning the examples of an attribute? The higher the information gain, the more effective the attribute in classifying the training data, that its contribution is more. So we are calculating the gain of an attribute related to the what? The entire data set, that is equivalent to the entropy of the entire data set minus summation of the values related to an attribute altogether. So we are multiplying this with the ratio, or we can say the proportion of the examples, that is what about the attribute values we are considering, no? So that related to the what? Overall training set, then entropy of what? That particular attribute. So we can observe here the values of A represents the set of all possible values for the attribute A, and SV is the subset of S for which attribute A has value P. Means what is the attribute we have selected and that entropy has been calculated. So how many instances are there in the entire training set related to that? So that is divided by total number of instances. So this we can able to understand with an example. So next we will focus on the ID3 algorithm, that is iterative dichotomizer. So let us understand how actually it is going to work, and it will be it is pretty sure that once we gone through the example, so this will be what more clear. So ID3, that is a function, it is a recursive function where we are going to pass the arguments as the examples, that is nothing but the training examples, and the target attribute, that is target attribute here it is a binary outcome, that is the yes or no, true or false, like that, and then all the attributes related to the training examples. First, what we supposed to do, so create a root node for the tree. If all the examples are positive, return the single node tree root with the label as positive. So in this case, what happen if all the examples are positive? Then what is going to happen? The entropy will be 0 because it is properly classified. Similarly, if all the examples are negative, again in this case entropy is 0. So then there is no further confusion since all the examples are negative. So we are returning the single node tree root with the label as negative. So if attributes as empty, then return the single node tree root with label is equal to most common value of target attribute in examples. Otherwise, if this is not the case, we are going to begin, means we are selecting the attribute from the attribute set that best classifies the examples. That is depending upon the attribute selection measure. So we are using the entropy and then information gain, and then we are selecting the attribute. So now the decision attribute for root, that is we have chosen this attribute. Now for each possible value vi of a, means attribute value, for every value add a new tree branch below root corresponding to the test, that is a is equal to vi. That is nothing but what? So if the attribute a has some 5 values, then we are going to construct almost 5 branches. So like that, if it has 2 values, then we are constructing the 2 branches. So let example vi be the subset of examples that have value vi for a. That is nothing but we are considering the examples, that is nothing but the subset of the examples. So we will see that what exactly. If example vi is empty, please observe here, then below this a new branch add a leaf node with the label is equal to most common value of the target attribute in examples. So now if there is an empty case, so when there are no attribute values are there, so we are adding the leaf node with the label as most common value of the target attribute. Otherwise, below this, a new branch, add the subtree. What is that? So we are creating the another subtree. So under that again, so the process has to be repeated. So for that recursively again, so we are calling the function ID3. Please observe here. Now examples vi, example vi's. Now your data set is partitioned, and then we are focusing on what? The branches here. So if the data set is partitioned into 2 branches, so we are calling this function again two different types, that is for the left partition and then again for the right partition, and this is going to continue recursively until and unless so we are able to find the leaf node, that is a further partition is not possible. In that level we are going to reach. So please observe here examples of, that is vi, that is we have partitioned that is the branch we are considering and the target attribute, and we can also observe here. So now in this case we have not taken the attribute which is already selected as a root node or the intermediate node. So other than that, the remaining attributes are passed, and again these steps are repeated, and then finally once all the attributes are explored, and then we are able to go through all the branches and further that is the training examples are not further partitioned, but till that time we are going to repeat this, and the outcome of this algorithm so is what we construct a decision tree which help us to further classify an instance without the target outcome. So when we give the instance without the target outcome, so we can use the decision tree to determine the target outcome. So next we go with the advantages of the decision tree. Very important aspect here. It is simple to understand as it follows the same process which a human follow while making any decisions in the real life. So now what we have to observe here, so how the human beings they are going to take the decision. So in the same way the decision tree approach will help us to help the machine to take the decision. So it can be very useful for solving the decision related problems, and it helps to think about all the possible outcomes for a problem. And also there is a less requirement of data cleaning compared to other algorithms, since it is a robust approach, so that we are using the statistical measures, that is to determine the node, that is the root node, that is the attribute which is considered as the root node. So it is going to give the maximum contribution in the decision making. So there is a less requirement of data cleaning compared to the other algorithms. So what are the disadvantages? The decision tree contains lots of data, which makes it very complex, because you can observe here. So if the data set contains n number of attributes, and you have to explore all the n attributes in order to find which attribute is considered as a root node, then it may have an overfitting issue which can be resolved using random forest algorithm. That is the overfitting in the sense it has when the decision tree ended up with multiple branches and there are possibilities few branches are unwanted. So that leads to the problem of overfitting that can be resolved using the random forest algorithm. For more class labels, the computational complexity of the decision tree may increase. See, if it is a binary classifications, then there are only two outcomes, that is positive or negative, true or false, yes or no. So if it is a multi-class classification, then more than one target labels will be there. So in such case, the complexity of the algorithm, that is the decision tree approach, will be increased. So in the next video, we'll be discussing the problem that is related to the decision trees.